Question number 101. Match the phytohormones given in column 1 with their precursors given in column 2. So these are the phytohormones given in this particular column and these are their precursors. So you have to choose the correct option. Ethylene is a gaseous phytohormone and its precursor is methionine. So A matches with second. Only fourth option is the correct one according to this. All other are ruled out. B. Cytokinin matches with tRNA as RNA is the precursor for the cytokinins. C. Fourth means gibberellin. Acetyl coenzyme A. Yes, for gibberellins the precursors are acetyl coenzyme A, and abscisic acid has a precursor called xanthine. So D matches with 1. So the correct option for the given question is option number 4. Let's move on to the next question. Question number 102. Auxin promotes the apical dominance, whereas it is counteracted by. Complete the statement by choosing the correct option. First option gibberellin, second cytokinin, third ethylene, fourth ABA. This auxin is the first isolated plant hormone and this promotes apical dominance. What is apical dominance? When auxin is present at the apical position, it prevents the growth of lateral buds. So this is called apical dominance. When it is present at the apical position, it is dominant. It will prevent the proliferation of the lateral buds. So this apical dominance is due to auxin and it is counteracted by cytokinin. So the correct option for the given question is option number 2. Let's move on to the next question. Question number 103. How many ATP molecules will be formed from complete oxidation of 2 molecules of 3-PGL in an eukaryotic cell? First option 34, second 40, third 36, fourth 42. These are the some diagrams which I have picked from your NCERT. And now try to understand in this particular question, it has been asked that from complete oxidation of 2 molecules of 3-PGAL. So find out where in a eukaryotic cell this 3-PGAL is formed. In glycolysis, when you start the breakdown of glucose, you will find this 3-PGAL somewhere here. So this is a phosphoglyceraldehyde or glyceraldehyde 3-phosphate. After the formation of this, you have to count the number of ATP molecules. After 3-PGL, there is a formation of 2 NADH. So in glycolysis, NADH and then 2 ATP, again 2 ATP. So this is 4 ATP. The next step is, now there is a formation of pyruvic acid at the end of glycolysis. So this pyruvic acid or the pyruvate enters into the mitochondrial matrix where it converts itself into acetyl coenzyme A, and this step is called link reaction. So in link reaction, there is formation of 2 NADH plus H plus. Now the last is when there is formation of acetyl coenzyme A, and in Krebs cycle, this acetyl coenzyme A enters into the Krebs cycle where this combines with the oxaloacetic acid to produce the citric acid and finally the CO2 and H2O. This is the complete oxidation of glucose. So in Krebs cycle, there are production of 3 NADH molecules in one cycle, but here it is asked from 2 molecules of 3-PGL. Hence, it will be twice. So see the calculations of Krebs cycle 2. In Krebs cycles, you will find the 6 NADH2, 2 FADH2, and 2 GTP molecules. Now calculate the total ATPs, but before calculating the total number of ATPs, you should know that 1 NADH2 gives us 3 ATP in ETS and 1 FADH2 gives us 2 ATP in ETS. Now calculate it. Here it is 2 NADH2 molecules, so 2 into 3, 6 ATP plus these 4 ATP. So total production of ATP from glycolysis is 10 ATP. From Link's reaction, it is 2 into 3, that is 6 ATP. In Krebs cycle, it is 3 into 6, 18 ATP plus 2 into 2, 4 ATP, and these 2 ATP, so directly you can add 2 ATP, which gives you 24 ATP in total. So now add these total ATPs from glycolysis linked reaction and the Krebs cycle. From glycolysis 10 ATP plus 6 ATP from Link's reaction plus 24 ATP from Krebs cycle, which gives you 40 total ATP molecules. So the correct option for the given question is option number 2. Let's move on to the next question. Question number 104. In electron transport system of respiration, which enzyme complex is odd with respect to the electron carrier? First option complex 1, second complex 3rd, third complex 4th, fourth complex 5th. See over here, this is the electron transport chain from respiration. On the inner mitochondrial membrane, there are some complexes which are present. This is the complex 1, this is complex 3, this is complex 2, this is complex 4, and this ATP synthetase is called complex 5th. These all 4 complexes transport electrons from one complex to another, but this complex 4 transfers protons, not the electrons. So this transfers protons from the intermembranous space to the matrix to synthesize the ATP. So the correct option for the given question is option number 4. Let's move on to the next question. Question number 105. Maximum energy is released during conversion of first option glucose into pyruvic acid, second glucose into ethyl alcohol and CO2, third pyruvic acid into acetyl coenzyme A, fourth pyruvic acid into CO2 and H2O. See, the maximum energy is released during complete oxidation of any substrate, and complete oxidation takes place during aerobic respiration. So see here, glucose into pyruvic acid, this is glycolysis. The net ATP production from glycolysis is 2 ATP. Second, glucose into ethyl alcohol. So this is alcoholic fermentation in which the net ATP production is again 2 ATP. Third is pyruvic acid into acetyl coenzyme A, in which from one molecule of pyruvic acid to acetyl coenzyme A, there is a production of one molecule of NADH2. And in the last option, pyruvic acid into CO2 and H2, this shows the complete oxidation of the pyruvic acid, and during the complete oxidation, maximum energy is released. So the correct option for the given question is option number 4. Let's move on to the next question.